So we'll start to get a little bit into the tech weeds here a little bit.
Yeah.
On the right is a stacking diagram where you can see all of the Revit models that we developed with our engineering team. And there's 13 in all, and all these things sort of crash down onto each other to make a combined model that we delivered as a coordinated model for the construction manager to use. And we freely share these models with contractors and the owner for simply the availability of the thinking that's embedded in the model. Sometimes we can't convey all of that in a 2D drawing, which is currently still the way we have to deliver this building, but they can understand a little better about our pipe routing and the complex routing of ductwork and things like that, and how we get from the basement all the way to mechanical equipment on the roof.
Hmm.
So the text, I'm not going to read it all, but it is important to kind of highlight the blue text there that the university really wanted to hire the highest end team that they could, both from a design and coordination standpoint, and also one that could deliver the most modern building. And we felt that we and they felt that the best way to do that was use the most modern delivery techniques, which is ultimately building information modeling. This was not an IPD project, but we definitely acted as if it were, simply because the contractors were always sitting at the table when we were designing. They were weighing in with cost and thoughts of constructability, and we felt it was a great way to collaborate and kind of get feedback real time on a lot of things we usually have to deliver a submission for and get pricing back on.
Yeah, I guess one question here. So just to kind of, I mean, this is a really interesting diagram. So I'm going to guess sort of at the top here, this is where we have, your architectural sort of skin model, maybe. Is that right?
Right. Yep,
And
there's
then,
actually two different ones. Yep.
okay. And then this guy right here, the second one from the top it looks like it might be some of
That's
the
the
MEP
those
systems.
are those are two different laboratory models. So the
Ah,
laboratory infrastructure was different from the mechanical systems, which was the next layer down.
okay.
So those are the mechanical, electrical, plumbing, all of the MEP nuts and bolts.
Okay.
That's another two models, and then the bottom one obviously is a structural model.
Okay.
And then the final one is the site model, and we'll talk a little bit more about that later. But the site model was a little more robust than the typical just topography and cuts into the landscape.
Okay. So let me think here. So the way you guys were working for this project, so you were saying this is the structural model, right?
Yep.
Um, so you guys are all, uh, I guess there's probably a couple of layers to this, right? So you guys specifically went out to find structural consultants, MEP consultants, maybe even lab planning. Maybe you guys do that in-house, I'm not entirely sure. But you specifically went out to find people who could work this way and who could produce design models for you. Is that correct? Do I have a good idea
That
of that?
absolutely right. We Ayers Synchros has the mentality that we want to work with the best engineers, and we really only work with engineers that work in Revit with us, and we
Hmm.
find it's the best way that we can collaborate and coordinate, frankly, our designs to deliver what we hope to be the highest quality design that we can, so that at the end of the day, the client's not paying more than they need to. It's
Sure.
not taking longer to build. So yeah, that's our kind of mandate in house.
And so the way that you guys are doing that, I mean, because it's one thing for them to make a model, but actually getting into the nuts and bolts of how that really works, you probably have something in your agreements with them where they're, instead of providing CAD drawings for coordination, they're providing BIM models up to a certain level of modeled specificity, and then you guys are doing different, you have regular meetings, and somehow you're doing clash detection. Could you talk through how that actually works?
Sure. The At the outset, we deliver a BIM execution plan
Hmm.
to all of the engineers,
Okay.
and what that does is define when things are modeled and to what level they are modeled. So, you have your level 100 models for, really early design stuff, level 200 for into schematics, 300s into the design development. But what that means is I want to see anything that's an inch and a half or greater modeled, because when you get out into the field, it's much harder to move those things once they're in place. So
Hmm.
if they model down to that certain extent from design development forward, then that gives us much better chance to find errors as a result of interferences, and that's what that little text box says, that we were able to reduce those errors simply by uh, making sure that everybody understood what was expected of them at the beginning.
Hmm.
And then starting in DDs and beyond, we would do monthly Navisworks coordination sessions, clash detection sessions, and that was hosted in our office, but everybody would log in via Works and webinars, and that would let us focus on different parts of the building, and we would assign tasks out of those meetings, and at the next meeting everybody had to come back with those things corrected.
Okay. And how are you actually doing the coordination? I mean, you're bringing them in, you're bringing the models into Navisworks, or you're doing some sort of preliminary, clash detection using a Revit model in Revit, or how are you doing it?
Yeah, that was all done in Navisworks.
Okay.
So export from Revit direct to Navisworks, and then all of the clash detection was done in there. And then before the meeting even started, we would issue the clash detection reports to the consultants so they could kind of get a sneak preview of what was going to be expected of them during the meeting.
Okay. Okay. Yeah. So then, really, the meetings were talking through those. So that's really important, and I think key that you guys are issuing those reports prior to the meeting, and the meeting is really just serving the purpose of, is there something we need to talk about here, or
Right.
is it just, duh, I need to move that thing, right?
Yep. There was a lot of that. Yeah.
Sure, sure.
You're showing your pipe going right through your duct. Why are
Yeah,
you
yeah.
drawing it like that?
Yeah. Okay. Okay. Cool. Uh, so someone's asking if you can share maybe the BIM execution plan, and if you can't, I know that there are some good baseline BIM execution plans that we can share that are, I think a couple of universities have put them together. So I know we can share that.
Sure. Yeah, yeah. Ours is loosely modeled after the Penn State
Yeah. There you
BIM
go.
execution plan.
Yep.
That's kind of the Cadillac right now. But we kind of go into another level of, we stay away from the AIA LOD document, and we kind of dive into a little more into specifically when a structural element is modeled, and at what stage is all of the vertical and horizontal ductwork modeled,
Hmm.
and on and on. So we can certainly share the execution plan with you, Mark, and then you can
Okay.
distribute that maybe with the final result.
Okay. Cool. And then Lewis is asking how long was each meeting. I'm going to guess they vary depending on how many changes there were based on the design and based on the subsequent number of clashes, right? So
Yeah,
couple
yeah.
meetings,
So
couple
yeah,
hours from time to time, right?
exactly. Typically in the early stages, there's not a ton to coordinate just because things aren't getting modeled yet, so they're shorter. But the deeper you get into CDs, the longer they'll last. So they could be a couple hours or more, and then people will start to nod off. So you have to come back again.